Hey folks, so what we're doing today is building a wire harness for a turbo engine. I'm using some parts supplied by my buddy Jeff to do this, which includes a mass airflow sensor, which is different from an airflow meter like on the traditional turbo that has the flap. This one actually uses the hot wire like a more modern setup. It's using a ECU out of a 1986 300ZX turbo. He gave me the 300ZX wiring harness, but there's a lot of extra plugs on that thing. It's not used. I'm not sure it's configured. It's not obviously not configured for an L28. It's configured for a B6, so that's a problem. Maybe it's not a problem, but I figured, what the heck? He had some extra connectors in there for the computer. So I said, well, heck, that were cut off from a donor car. So I just decided it'd make more sense to just build the wire harness from scratch. That way I'm only putting in the wire harness what I need. There's a few subtle differences on how the fuel pump is turned on. Plus, as usual, I want this to be a plug-and-play situation. So I take this wire harness, I will plug the 4-pin, it's actually a 6-pin, but there's only 4 pins that are used. So always on, switched on, a pump out, and can't remember what the other one is. Oh, and a start signal. So that's under the dash of a standard 280Z that works with this particular wire harness. The wire harness I have installed in this engine is a standard 280Z wire harness. So what I'm trying to do here is make this, like I said, as plug and play as possible. So you simply will install the wiring harness, hook it to the motor. You will plug in that 6-pin, 4-pin connector under the dash. It'll be a little bit different with respect to how the distributor works, because it's a different kind of distributor. So it won't be using the in-the-car ignition module. It'll be using a standalone module that's powered by the computer. So that's the only real deviation. Not really, I just don't use the stuff that's in the car for the ignition, for the spark. So anyway, to recap what I'm doing, I'm using the wire harness on this 280Z as a map to help me map out where the components are going to be. Again, I want it to be as close to a stock configuration as possible, so the lead dress approximates what the 280Z has, the length of the leads, where it goes through, how it'll bend around inside the engine bay, blah, blah, blah. So let me show you what I've done so far. Let's just spin this down. Well, I'm going to take you off the stand now. Okay, so this is 3 leads for there's a hot lead and a switch lead, and these green leads are the switch to the ground through the ECU. The red leads are hot all the time through a fuse link. That's a 654. This is 1, 2, 3, same deal. The red is a hot all the time through a fuse link. The green leads are the switched grounds, the fuel injectors. Here I have, this is the crank angle sensor. This plugs into the distributor. The wire colors were matched so that it's just there'll be no confusion how to hook that up. I just solder that on. And like this, I'm talking about the lead dress. I'm kind of just using the existing wire loom as a guide to fit things down through. Here's a throttle position sensor. I didn't have, they called for a purple and blue. I don't think I had a purple and blue, so I just used a solid blue, and it had a blue with a green tracer, which is what this has, so that's fine. So that's close. I've never seen a purple striped wire before. The loom comes down, obviously, again, mirroring this existing loom for length, so that way I know it should fit through the firewall and everything just right. This is the split off, this big fat wire here. That's goes to a fuse length. It actually goes up and branches into, I think that's a 12 gauge. It branches into a 14 gauge, and it branches into an 18 gauge for all 6 of the injectors. So I have a fuse link connection there, and again, I'm mirroring this is what the wire that wraps around the back of the engine alongside the cowl in a stock 280Z. So I'm just going to follow that right along with it. Made it the same length, so it should link up to a fuse link that goes to the battery. What I have left to do is the mass airflow sensor, which is a 6-pin connector. It doesn't work with this one at all. That's a 7-pin, but I have the connector. I've already bought that, so I'm going to wire that up and connect that to this loom, again following this direction. Outside of that, it's really not a whole lot more in the way of sensors. I have the knock sensor to hook up and the temperature sensor. Now it's a little bit different on the 280Z, because on the 280Z the temperature sensor, the cylinder head temperature, CHT, goes through to a pickup here at the thermostat. The turbo model has a different kind of cylinder head temperature sensor that actually plugs into the side of the car. It's not in a water jacket. I'm not sure which I'm going to do. I'll probably just make the lead long enough that it can go either way. So if you don't have a cylinder head that's compatible with that kind of a temperature sensor, you can go to the one for the thermostat. They work the same. It's just a matter, I don't know why they moved on a cylinder head. So I have a cylinder head temperature sensor to hook up and a knock sensor to hook up. That's the only thing that's not addressed by this at all. So what I'll do is it will come out and go along with that red wire, because remember, that red wire is the lead that goes along the back side of the engine. So it would make sense to take the knock sensor, at least the knock sensor, maybe the cylinder head temperature sensor along with it, along that wire, and then it'll branch out so it can plug into the knock sensor, which is located. So the wire is going to come around the back, around here, and it plugs in right here and right here, and then it continues on around the back side and hooks up to the battery, which is approximately right here. So that's where we are. There's a few other things I'm concerned about. And then of course there's the O2 sensor, which has a special kind of sensor. That's a 3-wire sensor, a heater, and that's called a titania sensor, which works different from the standard O2 sensor. The titania sensor apparently is something that varies in resistance. It doesn't produce a voltage. A little bit different, and I don't think it'll fit that bung. So I don't know what I'm going to do on that. I'll have to either find a way to put a different bung in or change the thread size or something like that. I don't know. But besides the O2 sensor, the knock sensor, and the temperature head sensor, the harness is essentially done, and the airflow meter. Doesn't sound like still got a lot to do, but it's getting there. Let's see, what else was I going to mention about it? Oh yeah, the biggest problem I've got here, come over and look at the turbo. Now, so here's your O2 sensor. It'll be a 3-wire sensor. Here's where it gets a little complicated. There's no idle adjust screw on this intake manifold for the turbo engine. The idle is controlled by this vacuum solenoid here, which duty cycles and allows a certain amount of air. I think it defaults to full speed idle. So if you don't do anything, it idles high. In order to make it idle low, you have to duty cycle it more frequently, and that cuts off the airflow. I think that's how it works. I'm trying to remember. I mean, in other words, when you turn it on, it cuts the airflow off, the bypass air. So that's a little weird. It's controlled by a vacuum control to this modulator, and this modulator plugs in here. There's actually an EGR control and a idle control. I'm not as worried about the EGR control as the idle, because I want this thing to be able to idle. The problem, it seems, is there's from what I've read and everybody's posted so far, is there's incompatibility between the output from the ECU to the type of solenoid that would control the bypass air. In other words, on the 300ZX, it doesn't use a vacuum controlled thing here. It's actually got a solenoid built right into this bypass air, and the solenoid, I presume, duty cycles a certain amount of bypass air. Whereas this model uses a vacuum line, and the solenoid is down in this modulator here, which pulses a vacuum. I don't know why it wouldn't work. I mean, unless there's just some kind of impedance mismatch, or the duty cycle is just drastically different, which to me, would, frankly, I'd be kind of shocked they make that big of a difference. I mean, all you got to do is duty cycle it and then control it. Maybe it's like an invert, you know? In other words, when this thing duty cycles on, it slows down, whereas maybe the other one duty cycles on, it speeds up. If it's something goofy like that, well, that's not a problem. We can make an inverter that will just flip that signal. You know, that's not that tough. So I'm going to have to do a little more research to find out what's going on there. But if it's as simple as just flipping the cycle on that, well, that's no big deal. So maybe that's all it is. If anybody knows how that turbo bypass air solenoid works, is it like on to speed it up, or is it on to slow it down? Because I know this one's on, vacuum on speeds it up. No, vacuum on slows it down. So solenoid turns on, it slows down. Turn the solenoid off, it speeds up. Maybe that's the whole issue. And like I said, if it's just a matter of inverting the input signal, that shouldn't be hard to do. We could do that with a power transistor, you know. So anyway, I really want to be able to control the idle, though. That's the bottom line. So I'm really hoping somebody's been down this road before, and you know, the standard option will just go in here and you just adjust the idle, you know, and just don't worry about it. Well, yeah, I know, but I'm kind of weird about having things that work right. I think I could literally disable this and just go in here and adjust the bypass air. But then it's a fixed idle, so it's not going to speed up or slow down when it wants it to, which is bizarre to me because it already has a bypass. It already has a kind of a bypass air for the AC. So when the AC comes on, you put a vacuum here and it speeds up. So maybe you don't need that. Maybe just block it off and the heck with it. It might be a simpler solution rather than make it more complex than it has to be. I mean, if I can disconnect this vacuum, adjust this bypass air right here, which is essentially the same way a 280Z does, has a bypass, and you just screw it, speed up, slow it down, and forget all this nonsense, forget that vacuum modulator, and this is still here to control the AC. Yeah, I'm starting to like that idea better already. Anyway, if you have any comments about that, let me know. As I progress, when I get the airflow meter hooked up, I'll show you. Oh, this is what I'm using. So I'm just going through each one of these injectors. Now there are different injectors for the turbo versus the non-turbo, so there's a little bit of wiring, you know, color coding to get done. But you get all the injectors done. I've got the exhaust gas sensor to do. The switch is done. The crank angle sensor is done, and the airflow needs to be done. Now, like I said, over here it gets a little complicated with respect to how the fuel pump works. It's ridiculously overdone, so we can fix that real easy, and I'll deal with that when I get there. Anyway, thanks for watching. Bye.